We missed a few minutes of recording, and so this is the slide, the problem that I was going over, and I want to just kind of go over the slide again for people who are tuning in later or watching again. So this is related to problem 3000, problems book number 10.27. And the problem relates to the biceps of the arm and how much force the biceps has to exert. And so basically, just to kind of talk through that problem, the first thing we do is we draw in the picture of the arm, and we have to get all the forces in there. So the biceps is exerting a force that, according to the picture, is upward. It's located 3.5 centimeters from the elbow, and they give us an upper angle of 20 degrees here, which means there's a 70-degree angle at the bottom. And then we're also given the force of gravity, or the weight of the arm, which in this case, it's not in the center of the arm. The arm is 35 centimeters long, and the weight of the arm is a little bit more, the arm is a little thicker toward the elbow, and so they gave us a center of gravity only 10 centimeters away from the elbow joint. So that force of gravity is not at L/2. It's not in the middle. It's a little bit closer to the elbow. And then finally, we are holding a 20 Newton weight in our hand. And so that 20 Newton weight is located at a distance of 35 centimeters from the hand. So what we did then, and this may overlap a little bit because I realized kind of midway through this example, so if you watch this video, then you may fast forward through the other lecture video. But we wrote down net torque equals 0, choosing the pivot point at the elbow, because there's some unknown force at the elbow. We don't really know which way it points or how big it is, so we can cancel it out by choosing the elbow as the pivot point. And then we're solving for the torque from the biceps, because within the torque from the biceps is the force from the biceps. So following the same pattern as our other problems, we do the algebra, we solve for the force from the biceps. And I noted here that since the angles for gravity and the weight are 90 degrees, those angles are 90 degrees, so sine of 90 is just 1, and so those signs just kind of disappear. And we put in our lengths that were just given, and the forces which are just given, the angles which are given in the picture, and we get a force from the biceps of 410 newtons. So you can go to the video from class after this and see the discussion about the size of this force. To lift 20 newtons, we need a much, much larger force in our biceps. And there's a little discussion in an extra credit associated with that. So take a look. Sorry that I missed the first part of this example in the original recording. Thanks.